Hi, geometry students. This is Mr. Schuessler. We are going to talk about algebraic proofs now. So algebra is a system with a set of numbers, operations, and properties that allows you to perform algebraic operations. The following table summarizes several properties of real numbers that we have studied previously in algebra. For example, we have the addition property of equality. If A equals B, then A plus C equals B plus C. Now, you don't need to memorize these. All of these properties will be provided for you on an exam or project. You will find on PowerSchool Learning a summary of the postulates and the properties of real numbers, which we have here. So you may want to take that and either print it off or have it as easy access for you while you are working on practice problems or studying for an exam, etc. Make sure you do know how to use and reference each one of these properties. Properties of real numbers that we have here. You recall the substitution property. If A equals B, then A may be replaced by B in any equation. So let's look at an algebraic proof example. So we want to justify each step when we're solving an equation. So the problem is prove that if negative 5 times x plus 4 equals 70, then x is equal to negative 18. So I'm going to walk us through each step here. So for each step that we do to solve this problem, we need to justify it using our... So we start off, as you remember, with the distributive property where you're going to distribute negative 5 into x and positive 4. Next, we have our substitution property of equality. We know here that negative 5 times 4 is equal to negative 20, so we substitute that in. And then we are writing that down here on the right side. We then do our addition property of equality. As you recall, what we do to one side, we have to do to the other to keep the equation true. And then we have, again, our substitution property of equality, because we know that 70 plus 20 equals 90, and negative 20 plus 20 equals 0. Then we have our division property of equality. Again, our substitution property of equality. And then we arrive at our answer. X is equal to negative 18, and x is equal to 8. And so we provided justification for each step. So that is an example of an algebraic proof. So just like we had here, we kind of had our statement and then our reason. Now, I also want to touch on two-column proofs, also called formal proofs. So a two-column proof contains statements and reasons organized into two columns. A two-column proof will do likewise. So let's look again at, this time, a formula from converting Fahrenheit temperature to Celsius. So Celsius is the temperature we use here in Hong Kong. In the United States, for example, they use Fahrenheit. So we are given the Celsius, then the formula to convert Celsius to Fahrenheit temperature is this equation we have here. Write a two-column proof to verify this conjecture. Begin by stating what is given and what you have to prove. So we're given this up here. That's why we have it written. Celsius is equal to 5/9 times F minus 32. And then we need to prove that Fahrenheit is equal to basically the inverse of that. So we start with our statement, our given. And for the first one, our reason is that it's given. And then we need to go about trying to isolate our F, as we see up here, that's our goal, is to get f on its one side. So we're going to use our multiplication property of equality. We're going to refer back to that table. Sorry. And then again, recall our substitution property of equality. 9 over 5 times 5 over 9 is equal to 1. And then 9 over 5 times 1 is equal to 9 over 5c. Then we do our addition property of equality. Again, our substitution property of equality back in. And then our symmetric property of equality. So we just flipped the equation to get it to the correct form. So we have the form here. These are the same, they were just flipped. And then this is the correct form that we're looking for, that we need to prove. So that is how we would do a 2-column proof or a formal proof. So you're gonna write basically like a T-chart, where you're gonna have your reasons on one side, on the right side, and then your statement on the left. Do a 2-column proof. I also want to talk about a geometric proof, which basically just incorporates geometric properties in. So for example, in our geometric proof, we have a reflexive. If AB equals AB, then our angle M1 equals M1. The symmetric proof, if AB equals CD, then CD equals AB. And our transitive proof, if AB equals CD and CD equals EF, AB equals EF. And here, AB equals EF. Geometry, the reflexive, symmetric, or transitive property. Let's look again at one more example. So we are given if FGJ is congruent with JGK, and JGK is congruent with KGH, then X is equal to 6. So we need to write a 2-column proof to verify this conjecture. Again, we're going to write down our givens. In this case, we have 4 givens, and then what we're trying to prove. Again, our proof is going to follow a 2-column proof format. So we're going to have our statements and then our reasons. We always start off with our givens at the top. So those are our givens. They're going to be the same as these givens. And our reason for that is because it was given to us. Then we need to start working through our proof. So we know that the angle FGJ and JGK are equal, and the angle JGK and KGH are equal. We can use our transitive property of equality, which I mentioned. So we know that FGJ equals KGH. Then we do our substitution property. So we know that this equals FGJ and this equals KGH. So we substitute those in, and then we go back to more of an algebraic proof. We're using our addition property, again our substitution property, our subtraction property, substitution property, and our division property of equality to end up with our final substitution property of 6 is equal to X. We need to do our symmetric property to change it to our proof that we're looking for, and that is what we end up with. So you do need to show all of your work when you're working through these proofs. I will be looking for that in either our project or exam that we have at the end of the unit, so make sure that you are showing all of your work and properly using the properties of numbers or the properties of. That is all for our lesson today. Go ahead and start working on the practice problems that can be found on PowerSchool Learning. Thanks for listening.